When we consider blood, we're faced with an organ whose marvelous complexity is matched only by its functional simplicity. Blood performs two major functions. The first is transporting oxygen and carbon dioxide, food molecules, ions, wastes, hormones, and heat to every cell in our body. The second is defending the body against infections and other foreign material. Blood is the only organ in the body that is fluid. Erythrocytes, or red blood cells, comprise about 40% of the blood's volume. They contain hemoglobin, a protein that gives blood its characteristic red color and enables it to carry oxygen from the lungs and deliver it to all body tissues. Blood serves as a highly effective delivery and disposal system for the body. To remain a vital organ, blood needs to be maintained and replenished. One way is by having wastes removed at regular intervals. The kidneys filter waste materials from blood and produce urine. These functions are performed by nephrons, which are microscopic units within the kidneys. Each bean-shaped kidney contains about 1 million nephrons. The components of a nephron includes a thin-walled, bowl-shaped structure called a Bowman's capsule, and within that, a glomerulus, which is a tuft of capillaries. In addition to their filtration responsibilities, the kidneys monitor the blood to ensure sufficient oxygen reaches every cell in the body. When the oxygen content of the blood passing through the kidneys is low, or the number of red blood cells decreases, the kidneys produce and release erythropoietin, or EPO, a hormone that stimulates unipotent stem cells to produce more red blood cells. This process is called erythropoiesis. Erythropoiesis takes place around islands consisting of white blood cells called macrophages. These islands nourish the developing red blood cells as they mature. The stimulated stem cell first evolves into a proerythroblast, whose nucleus is rather large, contains 1 or 2 nucleoli, and takes up most of the cell space. The proerythroblast becomes a basophilic erythroblast. Cell division ceases, the cell size starts to decrease, and hemoglobin synthesis begins at this early normoblast stage. In the next stage, the polychromatophilic erythroblast, the nucleus is more condensed than that of the proerythroblast. The cell continues to decrease in size, while progressively losing its organelles. Following this is the autochromatophilic erythroblast. Here the nucleus condenses further and is extruded. The reticulocyte stage is next. Hemoglobin synthesis is completed, and this immature erythrocyte enters the bloodstream. Once released, this new erythrocyte completes its maturation and continues the blood's oxygen and carbon dioxide exchange. The life of a red blood cell is approximately 120 days. Old and non-functioning red blood cells are removed from circulation primarily by the spleen. The kidneys are such highly efficient organs that all of the functions normally performed by 2 kidneys can be performed adequately by 1 healthy kidney. When illness occurs, the filtration process may be curtailed. In particular, chronic kidney disease, or CKD, is a slowly progressive decline in the kidney's ability to filter metabolic waste from the blood. The causes vary and include the detrimental effects of other diseases such as diabetes and hypertension. Kidney function is measured by the glomerular filtration rate, or GFR, which is the volume of fluid filtered within a unit of time in all nephrons of both kidneys. GFR is usually accepted as the best overall index of kidney function in health and disease. A decrease in GFR indicates the presence of CKD. It also precedes the onset of kidney failure. When the GFR falls below 60 milliliters per minute, the prevalence of complications of CKD increases, as does the risk of cardiovascular disease. CKD can be fatal, but heart disease causes 40 to 50% of deaths in these patients. In a healthy individual, there are enough red blood cells to carry adequate amounts of oxygen to all parts of the body to maintain our vitality. A shortage of red blood cells or a reduction in their hemoglobin content often hinders this process. We call this deficiency anemia. Patients with anemia experience various symptoms, including shortness of breath, fatigue, a rapid heartbeat, and chest pain, which can affect quality of life. Traditional erythropoiesis stimulating agents, or ESAs, such as darbepoetin alpha and epoetin, quickly bind to the erythropoietin receptors and are then quickly internalized and degraded. Therefore, sustained hemoglobin response requires frequent dosing or larger doses of ESAs. MIRCERA is the first continuous erythropoietin receptor activator and was designed to be different from shorter-acting ESAs. MIRCERA is chemically synthesized and differs from other ESAs. It has a new molecular entity with a molecular weight of approximately 60,000 kilotons, up to twice the molecular weight of epoetin. MIRCERA has a different interaction at the receptor level. It shows a significantly lower binding affinity for the erythropoietin receptors, which is characterized by a slower association and slightly faster dissociation compared with epoetin. MIRCERA activates the receptor and stimulates red blood cell production. Its reduced binding affinity for the receptor is thought to result in the very long elimination half-life, which in turn may allow a continuous receptor activation, thereby stimulating red blood cell production. MIRCERA provides a sustained concentration of unbound molecules available for receptor activation. This very long elimination half-life, up to 6 times longer than darbepoetin alpha, results in sustained concentrations of MIRCERA in blood, which may result in a sustained stimulation of erythropoiesis, allowing for the possibility of administration of MIRCERA at longer dosing intervals. MIRCERA, with its different molecular characteristics and receptor activity, demonstrates a high response rate, with up to 97.5% of patients treated in correction achieving target HB by a smooth and steady rise in hemoglobin and maintenance of stable hemoglobin levels with once-monthly MIRCERA dosing. The once-monthly ESA that will provide an effective and convenient way of maintaining hemoglobin levels stable in all adult patients with chronic kidney disease that are on dialysis and not on dialysis. This represents a significant advance in renal anemia management for patients, physicians, nurses, and practices.